In today's world, where fuel prices are rising as a result of increasing demand and less supply, you need to choose cost-effective fuels for your car to meet your needs. Thanks to the invention of Rudolf Diesel, the diesel engine has proven to be extremely efficient and cost-effective. Diesel fuel has a higher energy density, means more energy can be extracted from diesel as compared with the petrol. Therefore, diesel engines in automobiles provide higher mileage, making it an obvious choice for heavy-duty transportation and equipment. Diesel engines are attracting greater attention due to higher efficiency and cost-effectiveness. How is a diesel engine is different from petrol or gasoline engine? In a petrol engine, the fuel mixes with air compressed by pistons. The spark plugs ignite this mixture to move the vehicle. On the other hand, in a diesel engine, the air is first compressed. The fuel is injected at the top, and then this makes the air hot. The fuel then ignites when it hits the hot air, and then the vehicle moves forward. Which is better, diesel or petrol engine? Diesel engines are still more efficient than petrol engines, but less for those who are mostly engaged in city driving. Diesel cars also have more torque, which results in better fuel economy, along with impressive acceleration. So today, in this video, we look into how diesel engine works, along with its parts and functions. Like a petrol engine, a diesel engine usually operates by repeating a cycle of 4 strokes, that is intake, compression, power, and exhaust. In intake stroke, the air is drawn into the cylinder through the air inlet valve on the right as the piston moves down. In compression stroke, the inlet valve closes, the piston moves up and compresses the air mixture by heating it up. Fuel is injected into the hot gas through the central fuel injection valve and spontaneously ignites. In power stroke, as the air-fuel mixture ignites and burns, it pushes the piston down, driving the crankshaft that sends power to the wheels. In exhaust stroke, the outlet valve on the left will be opened to let out the exhaust gases, pushed out by the returning piston, during which the piston moves up and down twice. In a 2-stroke diesel, the cycle is complete as the piston moves up and down just once. It completes a power cycle in just 2 strokes of the piston. First is the intake and the compression strokes, and second is the power and the exhaust strokes. In intake and compression stroke, the piston moves up, where the fresh air enters the cylinder through an inlet port. After the intake process, the piston continues its upward movement and compresses the air and heats it up. Then the fuel is injected and spontaneously ignites the air. In power and exhaust stroke, the ignited air creates heat and the high-pressure gases exert a very high force on the piston, then the piston moves down. The downward motion of the piston rotates the crankshaft that sends power to the wheels. As the exhaust valve opens, the piston pushes the exhaust gases out of the combustion chamber, and the whole working cycle repeats. 2-stroke engines are smaller and lighter than 4-stroke ones, and tend to be more efficient since they produce power once during each rotation. This means they need more cooling and lubrication, and suffer higher wear and tear. Now let's find out what are the different parts of a diesel engine has, along with their functions. If you haven't watched my video on car engine parts, where I explained what are the basic parts of a car engine has, I'll recommend you to watch it once if you want. There is a difference between the components of diesel and petrol engines. It's because the diesel engine is have harder duty cycle, so the material used must also be adjusted. If we discuss, there will be hundreds of components on a diesel engine. For now, we will only discuss the main parts and their functions. Starting with the cylinder block. It is a primary component to place various engine compartments that support the working process of the machine. As you can see, the shape of the cylinder block is generally the same, but the details will be different. It's because these details are adjusted with all the components that will stick to this block. It is made of cast iron, which has a high degree of precision and strength. Inside the cylinder block, several components are placed. They are cylinder liner, water jacket, and oil feed lines. Cylinder liner. It will serve as a place up and down the piston. The components is made of iron and aluminum alloy located inside of engine block using press method, so it will be difficult to detach. Water jacket. Located inside the engine block. It is the place where the engine cooling process will take place. Hole-shaped water jacket are placed inside the cylinder block that surrounds the liner. Oil feed lines. The oil hole on the cylinder block serves to create the engine oil line from the cylinder head to the crankcase. This hole will support the engine oil circulation process to all diesel engine parts. Piston and connecting rod. Piston have a function to adjust the volume inside the cylinder. In this case, when the piston moves down, the volume of the cylinder will enlarge. When the piston moves up, the volume of the cylinder will shrink. The connecting rod serves to continue the up and down motion of the piston to flywheel. In general, there are 3 core parts on the piston are attached to it. They are compression rings, oil ring, and piston pins. Compression ring. These rings are elastic in function to prevent the occurrence of air leaks during the compression stroke. The way this ring works is to close the gap between the piston wall and the main liner. Oil ring. The ring printed under the compression ring serves to prevent engine oil from entering the combustion chamber. Piston pin. A pin located inside the piston to connect it with a connecting rod. This pin is tubular. When connected to the small end, it will function like a hinge. Crankshaft. A crankshaft is a mechanical equipment that transforms the reciprocating movement of the piston into rotary motion. A crankshaft connects with the piston through a connecting rod. The main objective of connecting rod is to receive reciprocating motion by the piston and delivers it to the crankshaft and rotates the flywheel, which further moves the vehicle. Crankshaft is made up of cast iron and also with special iron alloy that has high strength and anti-fastness. Some parts are attached to the crankshaft. They are crank pin. Crank pin is a pin that will connect to the big end on the connecting rod. Crank journal. The crank journal is a pin that serves as a shaft on the crankshaft in order to spin. Crank journaling will be attached to the cylinder block. Weight balance. This component is located opposite the crank pin. It functions as a counterweight, as well as to drain the oil to the entire inside of the machine. Timing chain assembly. The timing chain is included in the valve mechanism system. Its function is to connect the crankshaft and camshaft rotation with a certain angle. The component of this chain is located on the front of the engine. This chain will connect the sprocket gear from the crankshaft with the sprocket gear of the camshaft. Fuel injectors spray fuel into a car's engine using electronic-controlled valves, capable of opening and closing many times a second. They have a nozzle that distributes the fuel evenly for optimum combustion and efficiency. A car generally has 1 fuel injector per cylinder. So, if you drive a 4-cylinder car, it will most likely have 4 fuel injectors. By injecting the fuel, the system forces it into air that has been compressed to high pressure in the combustion chamber. Diesel fuel gets great mileage. They deliver better fuel economy than petrol engines. Diesel fuel is one of the most efficient and energy-dense fuels because it contains more usable energy than petrol and delivers better fuel economy. Diesels have no spark plugs or distributors. Therefore, they never need ignition tune-ups. Diesel engines are built to withstand higher compression, so they usually last much longer than gas-powered vehicles before they require major repairs. The diesel fuel used to be cheaper than petrol. It now often costs the same amount or more. Diesels still need regular maintenance to keep them running. You have to change the oil, air, and fuel filters. If you neglect the maintenance and the fuel injection system breaks down, you may have to pay a diesel mechanic more money to get things fixed because diesel engines are more technologically advanced than the petrol engines. So that's it. That's all about the diesel engines. If you think I have missed anything or you have any doubts, ask me